Today's lesson is on equivalent fractions. Equivalent fractions mean that they are the same. Here's an example. If you cut this apple along the dotted line, you would get one piece. What fraction of the apple would you have? You would have 1/2. If the second apple were cut along the dotted lines and you got 2 pieces, what fraction of the apple would you have? You'd have 2 out of 4 pieces, which is still 1/2. There's the 1/2 of that apple, and 2 out of 4 pieces for that apple. So equivalent fractions are the same fractions, but they have a different denominator and numerator. There is a pattern, though. Here's another way to look at equivalent fractions. Here are some fraction bars. They're exactly the same, except they are cut into 2 different parts. The first one is cut into 2 pieces, and the second one is cut into 4. However, if I were to put this one on top, they would be exactly the same. Now below, I have 2 fraction bars, and I can tell that one of them is equivalent to 1/2. This one, whose fraction is 3/6, is equivalent to 1/2. Looking at these 2 circles, do they show equivalent fractions? Well, looking at circle A, this is 1 piece is shaded out of 2, or 1/2. In circle B, we have 4 pieces shaded out of 8. So yes, they are equivalent fractions. Exactly the same amount is shaded on both of them. They're just cut into different size pieces. Here are some rectangles. Do they show equivalent fractions? If we look at fraction A, we see that there are 2 out of the 3 shaded parts. Fraction B, we have 6 out of 9 shaded parts. So they are equivalent, and you can see that in the picture. Fraction B, though, is just cut into more parts. Here in fraction A and fraction B, do they look like they are equivalent? If you said no, that's correct. Here we look at fraction of rectangle A, 2 out of the 6 are shaded. And in fraction B, 2 out of 10 are shaded. Since we have the same numerator of 2 and a different denominator, we know that they are not equivalent. A is cut into 6 pieces, B is cut into 10 same size pieces, so we know that we do not have equivalent fractions. I couldn't put A on top of B and have it match. So equivalent fractions means equal parts. Looking at these 3 sets of fractions, do you see any patterns? Copy these 3 fractions into your notes and write one thing that you see about them. Then answer the question, how did you get from one fraction to the other? I'll give you a hint. The numbers are going up, so if your numbers go up, that means you're either adding or multiplying. Pause the video and answer those questions now. So to find an equivalent fraction, you have to multiply the numerator and the denominator by the same multiplier. Please write that into your notes. Here are some examples. If I had 3/5, I could multiply it by 2 halves to become 6/10. Do you know what 2 halves is called? 1 whole. So really, all we're doing is cutting 3/5 into smaller pieces. Each section is being cut into 2 pieces, and that's why we end up with 10 pieces. Each of the 3 sections that are colored in are also cut into 2 pieces. Here's a picture to help you. Here I've shaded in 3 out of the 5 pieces. If I'm going to make an equivalent fraction, I can multiply by 2, which is the same as cutting every single piece into 2 parts. So now let's count up the green sections. 1, 2, 3, 4, 5, 6. And then if you count all of the sections, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you have the denominator of 10. Here's another example. We can also take 3/5 and cut each piece into 4 equal sections. Notice that 4/4, again, 1 whole. You must multiply by the same numerator and the same denominator. It must be 1 whole. And we end up with 12/20. So let's go ahead and try some of these problems. I would like you to find equivalent fractions for the following by using 3 as a multiplier. That doesn't mean you just multiply one number by 3. You have to multiply both the numerator and the denominator by 3. Please pause the video and write these into your notes. Now, using the information that you just learned, can you find out what goes into the box? Here's your hint. How would you get from 3 to 12? Well, if you do it that way, then you must do the same thing on the top to multiply the numerator. So let me do this example with you. I know to get from 3 to 12, I have to multiply by 4. Well, that means I have to multiply the numerator by 4 also to get 4/4. You can think of this as a whole, but you don't have to. 2 times 4 is 8, and let's see if our answer is correct. Very good. I have 2 more examples I'd like you to try into your notes. Here's the first one. Copy this down, and then I'll go on to the next one. And here's the second one. You can also rewrite this one as 3/4 equals blank over 16 if necessary. Please bring all of these back to class. If you have questions, please write them down and we'll discuss them during class. Have a great day.